So the main reason for the drop in gain in low frequency is due to the capacitive reactance. As I told you, right? So at very low frequency, the reactance is very high. So the gain is very low. As you slowly increase the frequency, the reactance slowly reduces and it will allow more current. So the gain will slowly increase. And after a particular frequency, the gain will become constant. So in the low frequency, the gain is dropping mainly because of the capacitive reactance. This capacitive reactance will play a vital role in determining the low frequency characteristics of your device. So if the capacitance value is very, very high, then seriously the gain will be very, very low, and the magnitude of gain, whatever value of gain you get, that value will be very, very small. Okay, all these capacitive reactance will be coming at the input during the low frequency region. In the high frequency region, you have all the parasitic capacitive elements. Those elements which are silent during the low frequency region, they all will be awake during the high frequency region, leading to drop in gain in the high frequency region. Remember, in low frequency and high frequency, the gain is variable. Only in the mid frequency region, the gain is going to be constant. Okay, remember that. So the frequency, how to find the boundaries of frequency where the gain is going to be constant. So you know this is the maximum frequency. Take 1 by root 2 of that. You draw a line. It will cut your graph at 2 points. So that is going to be F1 and F2. So F2 minus F1 is going to be called as the bandwidth. F1 and F2 are called as half power frequencies, or they are called as cutoff frequencies, or they are called as band frequencies, or they are called as corner frequencies. So many names are there for F1 and F2. From the maximum gain, take 1 by root 2. Why 1 by root 2 means I need the power to be half. So power வந்து half na, power is voltage V square by R. So when power is going to be half, voltage will be 1 by root 2 times. That is the reason why we take 1 by root 2 of your gain. See, we are plotting voltage gain, right? So if the power has to be half, voltage has to be 1 by root 2. So 1 by root 2 value to multiply the maximum gain, you will draw a line at that point. It will intersect the graph at 2 points, F1 and F2. The F2 minus F1 is going to be called as the bandwidth. ஏன் நம்ம half power எடுக்கிறோம்னா, so minimum half power should be flowing available at the circuit, maximum 100% power should be available. So minimum 50% is a condition for amplification. Minimum 50% power இருக்கணும். Maximum I can have 100% power. So my power should not drop below 50%. That is why I'm taking the half power frequencies. So remember, half power will translate to 1 by 2 P by 2. Half power na P by 2. And P by 2 is equal to V by root 2. Power half now, voltage and current will be divided by root 2 because power is proportional to V square. Power is proportional to I square. So power divide by 2 pannona, voltage and free current, I should be dividing it by root 2. That is why here we have written 1 by root 2 times the mid frequency value. And one more reason, power when you divide by 2, voltage and current should be divided by root 2. That is fine. And my device should be a minimum, it should be always having minimum 50% power always, because when you are going to design an amplifier, it should be having a minimum power available and the maximum power available. It should work always between minimum and maximum power. Here I fix the minimum power to be 50% and the maximum power to be 100%. So the minimum power, what all frequencies you get, that is going to be the frequencies F1 and F2. So you should always operate the device only between the frequencies F1 and F2. What will happen if I operate the device at frequencies less than F1 or at frequencies more than F2? Can anybody say what will happen if I operate the device at frequency less than F1 or more than F2? What will happen? I told you your device should be operated only between F1 and F2, or I can say F2 minus F1 is called as the bandwidth of your device. What will happen if I operate the device less than F1 or more than F2? What will happen in that case? What will happen in that case? Your signal will not be amplified, because in that frequency less than f1 or more than f2, the gain is going to be very, very less. So that is going to be a drawback for you. It is not going to amplify your signal effectively.